Wonderful introduction to cardiovascular disease, so I don't have to do it. I'm going to be talking about omega-3 fatty acids and particularly measuring blood omega-3 levels as a risk factor, a risk marker for cardiovascular disease. I'm living in South Dakota. USD is University of South Dakota, not San Diego, as I wish it was. Let's see if my pointer works here. It's a big red light. It is. So I live in Sioux Falls, which is why I have the four faces up here. What's that called? Anybody just yell it out? Mount Rushmore. Good. Somebody knows. A lot of times, you never know. Recently, I've taken a job in Richmond, Virginia, working with Health Diagnostic Laboratory, which is a group that is now offering this test clinically. And we'll see some of the reports that they put out on this now, but it's expanded considerably. Dr. Rosens, we're not going to go through all this atherogenesis, all these factors that relate to atherogenesis. These are many of the markers that we measure at Health Diagnostic Laboratory. But there are many, many factors here that are relating to cardiovascular disease. My primary interest today is one of them right here, which is a red blood cell that says omega-3 fatty acids on it because our blood test is done in red blood cells. And it is another contributor to this entire process. So what's the omega-3 index? We'll go over some of the evidence supporting it, how target values got set, how the omega-3 index actually compares to other cardiovascular risk markers, how stable are samples, what are normal levels, how much omega-3 do you need to actually get a healthy level, how good's the assay, how does it differ from lab to lab, and then how do you read a report. So that's what we'll go over here. First, just to begin at the basics of what are omega-3 fatty acids, and we begin with the essential fatty acid families in the human diet, the omega-6 family and the omega-3. Both of them are essential. They're not interconvertible. You can't make one out of the other. You have to eat both of these. They're called omega because of the structure of the molecule. This is the fatty acid, a classic omega-6 linoleic acid. It's a 18 carbon 2 double bond omega-6 fatty acid called omega-6 because if you call this the alpha carbon, then this is the omega carbon. It's the end, alpha and omega, and if you count back 6 positions, you get the first double bond. So omega minus 6 means that structure, which is consistent with all the fatty acids in this family, including arachidonic acid down here. Omega-3 fatty acid has a different structure right here, and just the presence of that one double bond makes a big difference in the metabolic effects of these fatty acids. Sources of these fats, of course, the omega-6 fatty acids, linoleic particularly, come from vegetable oils. There's a few vegetable oils that have alpha-linolenic in them, which is the omega-3 from plants, primarily flaxseed oil, but soybean oil is really where we get most of the omega-3, plant omega-3 in our diet, since about 70% of the oil we eat is soybean oil. It's the commodity. The fatty acids below this line are made by animals, not by plants, so arachidonic acid is synthesized by humans, by mammals. The omega-3, EPA, and DHA are made, are found in animal products. They're not found in plant products. Actually synthesized by single-cell organisms in the ocean primarily, which then get into the food chain of fish. So these are present in oily fish. When I say oily fish, I don't mean deep fat fried catfish, things like that, where the oil is actually in the muscle of the fish. Let's go first of all to, I think, I always like talking about omega-3 because of all the nutrients that we have that have been studied for cardiovascular risk reduction, none of them has the data, the solid scientific data, randomized controlled trial, prospective, hard endpoints that the omega-3s have. And this is one of the biggest studies, it is the biggest study to date that's been done with omega-3. It's called the Japan EPA Lipid Intervention Study, or called JELIS. This trial involved over 18,000 Japanese men and women, mostly women. As it turned out, all of them had elevated cholesterol. All of them were on a statin in the background. Half of them were given just a statin. The other half were given EPA, eicosapentaenoic acid. That's one of the 2 fish oil omega-3s. This is a pharmaceutical product in Japan. It's called Epadil. And the company that owns the Epadil is the one that funded this trial. They wanted to see if they could get a cardiovascular indication. Anyway, these individuals were followed for 5 years for major coronary events, defined down here as either sudden cardiac death, fatal or non-fatal MI, unstable angina, angioplasty, stenting, or CABG. If any of those events happened, that was that was counted as an event. And you can see here, if we just look at this panel here, this is the entire cohort of 18,000 people over the 5 years of the trial. The green line is the event rate in the control group, and the red line is the event rate in the EPA group. This is you can't see the numbers. It's a 19% risk reduction, statistically significant. So there was almost a 20% reduction in risk, which is a remarkable thing if you think about it, because the Japanese eat about 10 times more omega-3 than we eat already. This is one of the highest intake populations in the world for omega-3 fatty acids.